All right, so we're we're experiencing some slight technical difficulties, as you can see by the screens over here. I don't really know why this is not working. I'm going to call the screen people and see if they can figure it out. Do you want to come here and just see if there's something obvious that I'm like missing?
I don't know.
No, but you know, normally when it looks like this, something's up on the screen. Yeah. So I don't really know what there is. Yeah, I'm on VGA. This is definitely VGA. I don't really know.
Do you want to change your computer to try?
Can I ask a question? How many people in this room do not have like a laptop or some internet connected device that can display PDF, a tablet? How many people do not have that? So if I just basically ask people to look on their laptops, how many people would be screwed? You can look on with your guy next to you. All right. This is like ridiculous, but I mean, I don't think it's going to be a really long lecture, so why don't we just go ahead and do it that way. I guess another thing I could do, let's see if this works. We could try doing this. Oh, wait a second. I don't think that's not actually doing. Yeah, because the projector's just not working. Any backup's not going to help me.
Should I call those people from Mediatek?
Yeah, there's a thing here, a number you can call, but I don't really know. It's like I power cycled the projectors once. So I could do it again, but that's not really going to make a difference. Oh, now I'm in some like Macintosh hell too. It's so embarrassing. See, now I can't actually even see what's on my screen.
There's no phone number here. Maybe
There's no phone number? No. Oh.
But we could look at the website.
It's like courses.
It's possible that your VGA is not working. Will you try?
Yeah, all right, let's try that. The thing that violates that expectation is that it's showing up on this, right? It's just not showing up on that. Does that make sense?
So the VGA is working actually.
Yeah, I think this is working. It's just, yeah. Right now,
You still need to call them?
yeah, we still need to call them. Just hang on tight, everyone.
Should I tell them? That the projector is not working? Or...
Yeah, the projector's not working. This seems to be okay. I'm gonna take this back. All right. So this is what I'm going to do. We're just going to pretend that we're sort of in like some bizarre mix of the dark ages when people put things up on blackboards and the internet age where we can look at everything on the web. So please just look at the notes for this lecture on the web. And I'll just kind of like talk through them briefly and then take questions. So like I said, there's not really any new material here. This is just sort of really, it's just a way for you to give you guys another lecture's worth of time to kind of catch up before the midterm. Because I know things are kind of crowded together in this lecture. And my PowerPoint is also wedged, I guess, because of all the stuff I've been doing. Give me a second here. Because I want to see what I'm talking about too, right? It's like just kind of crazy, but that's the way I roll. All right. So, so I guess a couple of kind of overall comments. So one is I try and ask questions that are more about understanding than memorization. And I'll give some examples of that as we go forward. So this is mostly about the computational side of learning rather than sort of the information theoretic side. So generally, if there's a question that would make perfect sense to ask in a 601 class, then I try not to ask it here. I'm trying to sort of focus on the things that are sort of, different and complementary. In the test, we will be talking about things that were covered in the assignment. We will also be talking about things that aren't specifically covered in the assignment but I've just lectured on. Okay, so if there's something that we haven't done an assignment on, this year, like phrase finding, but I spent a significant amount of time in lecture. So for example, you guys haven't programmed in Spark yet, but I spent some time talking about Spark and the differences between Spark and kind of standard Hadoop. Those are kind of fair game for questions. So things that are just in the lectures but aren't in the assignments might be covered. So an example I have in here as something which is and I guess another thing is that there's some things that you implement in the assignments, and then separately in class I'll kind of talk about the analytic results, right? So there was a discussion of the hash trick and how you can view it as a kernel and what does that mean. There was a discussion of lazy regularization, and I had a formal argument that it should do the same thing as the regular regularization, but would have different computational properties. So those are the sorts of things I might ask. I might ask about sort of the analytic formal foundations of techniques that were used in the assignments. So that's another example. Some other general hints about studying. So if there's an assignment you've dropped, that's fine. It might kind of come back and haunt you, and there might be something about that assignment in the exam. So you should sort of be familiar with the materials that the assignments are meant to teach you when you're taking the exam. And you should be able to do the things that we spent time on. So I spent a lot of time in the lectures, basically sort of taking algorithms, tasks that you'd like to do, and then sort of teasing them apart and breaking them down into MapReduce steps. So that's something that you should be able to do on the exam. Obviously, you won't be able to like sort of do a lot of coding on the exam, but you should be able to look at a MapReduce pipeline and figure out what it does. You should be able to sort of be generally familiar with like the guinea pig pipeline that you guys worked with, and so on. So you should sort of understand that at a high level. You're allowed to bring in one sheet of paper, 8.5 by 11, front and back is okay. So a general piece of advice, not just for this exam, but all exams is if there's a question and you're not really quite sure what the intended answer is, sometimes that means you're not prepared. Sometimes it means we didn't write a great answer, a great question. And there's actually sort of a couple of different ways of thinking about it. And maybe when we were doing it and testing it, we only thought about one. So if there's something that seems to require some sort of assumption in order for the question to make sense, obviously raise your hand and ask if that's appropriate. But you could also write down the assumption you've made, right? So you say, well, this only makes sense if the instance vectors are sparse. then say, yeah, assuming the instance vectors are sparse. Was there a question? No, okay. Another kind of good heuristic, if you sort of get stuck on a question, you're not quite sure what the answer is. So usually that means we haven't really told you what the answer is, but maybe you could work out what the answer is from what you've been told. So if it's a situation where you haven't been told an answer, it's sometimes hard to recognize the answer is correct. So one possibility is like pick an answer, like true or false, or I think this is the way to do it, and then try and argue for that. So imagine you're arguing to an imaginary person, like the TA after you get your grades back, and see whether you kind of like buy that argument. So that's just a heuristic. If you kind of get stuck, you may think about doing that. Okay. So the other part of this slide deck I had was I basically just had some of the major topics that we talked about before the midterm, and I was kind of go through those. So one of them is basically Hadoop MapReduce type architectures. So I spent some time talking about this idea called stream and sort, which is actually independently useful, okay? But it's really my kind of personal way of easing people into Hadoop and MapReduce. It's not really a topic on its own, so that's not going to be heavily represented in the midterm. That's really sort of more of a pedagogical kind of thing. We will be talking about guinea pig. We will be talking about Spark. So those are questions you might get. We talked through a bunch of sample algorithms. We talked about how to do TF-IDF weighting. We talked about how to do phrase finding. We talked about how to do soft joins. So those are all things you might get questions about. So most recently, we talked about parallelizing learners. Okay, we talked about this iterative parameter mixing strategy. We talked about the streaming SGG method and these techniques for speeding things up, so the hash trick or the hash kernel. We talked about sparsifying the regularization step. And then Tuesday, we could very well have questions on the distributed matrix factorization techniques. So those are all things that might be covered. Obviously, some of these are easier to ask questions about than others. So there's some overlap. So just to give you some examples of things we might ask questions about. So here I've got a slide here, which is basically sort of a picture of Hadoop, this kind of like 30,000 mile view picture of Hadoop, where you've got nodes for workers, and we've got nodes. Oh, are you the guy to come rescue me and figure out why we can't see anything? So right now it's because this isn't plugged in, but yeah, all right. All right, what's your name?
David.
This is David. All right.
Greetings and salutations, all.
Yay, techies. Okay.
Nope, wait, there it goes.
That's the document camera, I guess. Right. Yeah. Okay.
Okay,
Okay.
be right back on and reset the projectors up there.
All right. Okay. So he's going to go back into that secret room upstairs and like reboot some things and see how that works. All right. So one question would be, there's a job tracker. Okay, that's the thing that monitors the progress of jobs. What would happen if that job tracker had to get rebooted? What data would get lost? What would you expect to happen? Maybe this has never happened to you, but you probably know enough about Hadoop to make a reasonable guess as to what things you would be likely to lose and what things you would be likely not to lose. Okay. Here's another example. Supposing I've got a big file, maybe the file is a terabyte. Okay, supposing I take that 1 terabyte file and I decide to shard it into 1,000 pieces to be distributed across the cluster. Should that take more time than sharding it to 10 pieces or not? All right. So how many people think it should take longer than sharding it into 10 pieces? How many people think it should take less time? How many people have no idea? All right, well, let's think about answers you might make and how you might argue for them, right? So I mean, there are two obvious answers here. It's less time or it's more time, right? So, and there's an experiment you could do to find out which one is which, right? So I would kind of think about things this way. So if we've got 1,000 pieces, that means each piece is a gigabyte. That's still a pretty big piece, okay? And they're going to be going to 1,000 different worker machines. So that would suggest that there's going to be a lot of, network I/O, okay? Because you're distributing this to many different machines, okay? On the other hand, the things you're distributing are much smaller, right? So I guess kind of my short story is I can imagine an answer going in each direction. But I think what would be important there is whether you sort of come up with sort of a good justification for what your answer is. So here's another question: where would a combiner run? Okay, so I've got these nodes here. Some of them are labeled as map nodes. Some of them are labeled as reduced nodes. So where would the combiner run? If I ask you to basically, ooh, look, it's moving. If I asked you to go ahead and go on that picture and check off where the combiners run, would you be able to do that? Or here's another example, all right? So here's some data in the Hadoop file system, okay? How many different disk drives is this data stored on? Okay, and there are a couple of different plausible answers. We've got 10 shards, okay? There's the number 3 in each column, right? So I think the good answers here would be, let's say, 3, 10, 30, or 10/3, right? Or I guess 13, you could argue for 13, right? So one of those answers is right. So do you know what the answer is, right? So if you kind of understand how HDFS is set up, the answer is pretty obvious. Otherwise, it's not. Okay. I don't really remember what I was talking about here. Oh, well, here's a good question. So these are just error logs. At some point, I generated an error and sort of showed you how to find it. Now, during the Hadoop assignments, you might have also generated an error and then found it. This is an old snapshot, so it's a little bit different. Okay. So in this particular case, there was an error, and I saw the same error for every map process. So why do I keep getting that error over and over again? Why are there 10 copies of that error? Okay. Again, if you sort of understand the basics of how Hadoop set up and worked, then you will know what the answer is, right? You get the same error because each of those workers is running the same task, and the error turned out to be an error that's going to get run whenever you run the task, right? So the error is a bug in the code. It's going to happen every time. And there are other errors that could be some sort of transient error connected with that worker, and you'd only see it once. Or it could be an error that's provoked by some particular piece of input, and you only see it once in a while. But this is one that basically just always happens. So here's another example is Spark. Okay, so I spent a little bit of time kind of talking about what happens here and why this is really useful. So Spark is nice because you can do loops. And one thing that's nice about being able to do loops here is that you can take the data and you can cache it, so it's stored in memory. So every time you go over that loop, you're working with data that's been cached in memory, so you're greatly reducing the amount of disk I/O you do. So when you do iterative operations in Spark, it tends to be a lot faster if you've done the appropriate caching. Okay. And there's some other things that are kind of happening magically behind the scenes. Okay. So one thing that's happening behind the scenes is that W, which is an internal variable in this little program, is being, every time it's computed, it's being shipped out to the cluster. Okay, so this code that gets executed is being shipped out to the cluster with every call. That's another thing that happens automatically in Spark, and doesn't explicitly happen in Hadoop. So if I asked you, should this run faster than iterating the same process in Hadoop, you should be able to say, yeah, it'll be faster. And if I asked you why it would be faster, you should be able to sort of articulate that, at least to the level of detail that I gave here. Here's another example. Okay, so this is some code we talked about. This is code to compute basically an IDF representation of documents. Here there's some things that I'm assuming fit in memory, and some things that don't need to fit in memory. Okay, so there's some things that I'm streaming through. So all the stuff here that I'm streaming through, okay? But there are also some things that I'm explicitly loading into memory, so there'll be a copy of memory in each mapper. Just to kind of like give it away, right? This function right here, loaded by, you're taking a view, you're loading it into memory, so that view's got to be distributed everywhere, and it's got to fit in memory. And then when you're streaming through, basically you've got a pointer to this object, which is a dictionary stored in memory. So this is kind of where we've made assumptions about how big the data is. You should be able to sort of identify those. And you should also say, well, if I didn't want to do this, what could I do, right? So if I didn't want to use this pattern here, we could also do it with a join. And that, of course, has some pros and cons. So again, that would be something you should sort of be able to kind of articulate what that is. So here's some stuff about parallel learners that we talked about more recently. I had this theorem here, okay? So this is the result from the paper, and we talked a little bit about what this meant, okay? So we also talked about the proof, okay? I'll tell you right now, I'm probably not going to ask you detailed questions about these proofs, okay? Probably not going to ask you to kind of step through and reproduce that proof or slightly extend the proof or something like that. But I certainly could ask about the theorems that are involved, right? So there's a consequence of this theorem, which I actually kind of pointed out. I said if you have uniform mixing, then there's this bound, and it's S times larger than the old bound, okay? So the number of mistakes is bounded by something which includes a factor of the number of machines you have. So that's something we talked about, and those are that's something I might ask about in a test. Or another example is just sort of understanding what it is that we've talked about, kind of in some level of detail. So this was distributed training strategies for the structured perceptron. The thing I talked about most was how do you distribute this learning, okay? But as I pointed out in the lecture, the fact that this was a structured perceptron actually has an impact here. So in structured perceptrons, there's more compute for each weight update. So it's a little bit easier than if you had a regular perceptron. So again, that's the sort of like kind of understanding question that would be good to be able to answer. And then I guess when we talked about the streaming stochastic gradient descent, we talked about this as first as sort of a trick, right? And then we also talked about it sort of in terms of kernels, right? And again, there are a bunch of questions I could ask about that. So the hash trick lets you control what? Does it let you control the memory footprint? Does it let you control the runtime? When I call it a hash kernel, what does that mean? Why am I calling it a kernel? What's the analogy to the kernel you might see for a kernel perceptron, let's say? So these are just some examples of the sorts of things I kind of feel might be interesting questions. I'm not going to say all these are going to be questions on the midterm. If you had to do all those, that would kind of be along the midterm. But it's just sort of to give you a sense. We've also put some sample questions up. So these are from previous midterms, and again, you should just sort of use a little bit of, intelligence. If there's something that, we didn't talk about at all in the lectures, then it probably means that it won't be on this midterm. So, the topics I cover in this course, not sort of fixed by a textbook. The topics vary a little bit from year to year, but the first half is pretty much the same. So those should be a pretty good indication of what kind of things we'll cover. Okay, so I'm going to stop now and just take questions from people about the midterm, right, or about the assignment, or about the course, and then we can break off. Okay, so like I said, this isn't really trying to cover a lot of new material. It's mostly just kind of giving you a break in the syllabus so you can catch up, and maybe give you some tips on studying. Yeah.
So what's the general advice for the cheat sheet? What should we write up?
What should you write up? Well, I mean, it's totally up to you, right? You can put anything you want on the cheat sheet. It could just be like, go William Cohen, be confident, right? So, I mean, so there's a lot of terminology in this course, right? And having some list of terms with maybe like a little bit of explanation of those might be helpful, right? If I'm going to ask you to write MapReduce guinea pig programs or something like that, you might want to have, some kind of condensed information about that on your cheat sheet, right? So I mean, it's really kind of up to you. I mean, this is the other reason I sort of let people do this is because I think it's actually a really good exercise. So if you go through the lectures, for most of the web pages that correspond to a lecture or a group of lectures, I have like a list of kind of like high points to kind of think of and remember. So that might be something you want to look at. So those tend to be like written as sort of questions or things you should sort of understand, right? You might want to look at this as well. Do I just know that? Or maybe I should like put like a little reminder for myself. Okay, so it's really up to you, but those are the sorts of things people tend to put down, equations, definitions, stuff like that that's hard to stick in your head. Any other questions? Yeah?
Can we get solutions to the assignment report questions?
Yeah, so we're going to try and do that before the test comes out. So how many homeworks do we have solutions out for? Just one, right? Is homework one the only one we have full solutions out for? All right, we're going to have a TA meeting and we'll talk about this. So I'll push for having those things out before the exam. Anything else? Probably won't have it for the last homework. Anything else? Okay, well, we'll see you guys Tuesday. Good luck.